Bismillahirrahmanirrahim. So let's do an example of an energy signal. As I told you, energy signals are mostly exponential signals and aperiodic nature of signals. So let's do an example of an exponential signal, a signal that is e to the negative t. This signal only exists when t is greater than 0. As you can see the graph of this. So this is e to the negative t. This is what that signal looks like, and as it goes and as the time passes by, this signal tends to go to 0. That's what that means. As the time increases, as the time reaches infinity, this signal tends to go to 0, and if this signal does not exist is 0. Otherwise, any other places beside this condition, this signal does not exist. So what is the definition of my energy signal? Energy signal, the definition of an energy signal is this: as t, as it goes from negative infinity to positive infinity, okay, you're taking the magnitude of this signal, squaring it, and you're taking area under the curve. All right, so let's apply this signal in place of x of t. So here's the thing that I'm going to do. Okay, so t, as it goes from negative infinity to positive infinity, exp negative t dt. Now what happened when I square this signal? So I'm going to square this signal. So when I'm squaring this signal, this is what I would get: negative infinity to positive infinity. Now this kernel, which is right here, when I square it, this would actually becomes exp minus 2t dt. So when I square this, it will become e to the negative 2t dt. This is what the signal would become. Okay, let's look at it. What are the limits that I need to put in? The limits that I need to put in: this signal does not exist anywhere else beside going from 0 to positive infinity. If I were to look at it, it does not exist 0 otherwise. So which means my integration limits are going to be 0 all the way up to positive infinity. As you can see it from the graph, that this signal is 0 otherwise. It only exists as t is greater than 0. So as you can see, this signal only exists. It does not exist here. It only exists at this point. So once I integrate this, so I'm going to reuse this rule. So integration of EAT is actually EAT divided by A plus C. So this is the rule that I'm going to use. This is that integration rule that I'm going to use. So once I apply this, what do I get? I get this kernel. So let me just so this is going to be positive infinity, t as it goes from 0, exp. So I have changed the limit to t dt. So let's go here. So now when I integrate this, this would become exp minus 2t divided by negative 2, and integration as it goes from 0 to positive infinity. All right, so this is what the definition would become. What it is, I just simply apply this rule of integration, and I have negative. Now here's the thing: whenever you have a negative in the denominator, whenever you have a negative in a denominator, what I'll do, I'll remove the negative and I can switch the limits. The reason I'm doing it, I'll explain this in a little bit. So whenever I have a negative in the denominator, you have to remember this: whenever you have a negative in the denominator, what can I do? I can remove this negative and I can flip the limit. So this would go on top, this would go on bottom. So this would become exp minus 2t minus 2, and the limit goes from 0 to positive infinity. Now here's something else I know about exponential function, which is really nice, because e to the 0 would give you 1, and e to the positive infinity would give you 0. Why? Let's look at the graph. If you were to look at the graph, as the t is getting bigger and bigger and bigger, this signal will tend to go to 0. That's why we have this condition. All right, at 0 it is going to be its maximum position. Okay, so once I apply this, now just simply applying this, so I'm just going to bring this out here and I'm going to solve it here. So what is this? So this is going to be e to the 0 would give me 1, e to the 0. So once I apply this here, so I can remove this now. I can remove this and I can make this only a positive 2. Okay, since I've already flipped the limits. So now what I'm going to do, e to the 0 in place of t, when I plug in 0, this whole thing would 0. So e to the 0 would give me 1. So this is going to be 1/2. And when I apply my limit of positive infinity, this whole thing would be 0. 0 minus 0 is 0. So 1/2 divided by 0. This would give me 1/2. So indeed, this is an energy signal. Why? Because this is a finite energy, isn't it? So this thing has an energy of 1/2. This signal has an energy of what? 1/2, which is finite. So the definition of energy signal is this, that you have energy which is going to be finite, but you will have no power. So I hope you like this small tutorial on the example of energy signal, or especially an exponential signal. And if you have any questions, please leave it in the comment section, and don't forget to subscribe to my channel.